Faculty Physics in Delhi Public World School, Kotputli. So today we will discuss the topic related to Term 1 syllabus named Motion Under Gravity. We will try to learn the tips and tricks related to this topic, and let's start the topic. Starting with the title of the topic is Kinematics of Particle. Kinematics of Particle means we are studying the motion without the application of force. Studying motion without knowing the value of force. In our syllabus there are two types of motion. First is motion in one dimension. Basically we are talking about the motion in straight line. Second one is motion in plane. That is the projectile motion that we study in our syllabus. So today we will study the one dimension motion only, and the title of the topic will be Motion Under Gravity. Title of the topic will be Motion Under Gravity or Motion in Straight Line. So starting with the just give me a moment. Okay, motion under gravity. Motion under gravity means the motion of a particle under the influence of Earth's gravitational field. Motion of particle under Earth's gravitational field. For our syllabus, we will assume for smaller distances like height approximately to 5 to 10 to 15 kilometers, we will assume that the acceleration due to gravity will remain same. Then the value of acceleration will be equal to g, approximately equal to 9.81 meter per second square. If acceleration is constant, then we can simply say that we can apply three equation of motion. We can apply the three equation of motion written as V is equal to U plus AT, first equation of motion. Second is S is equal to UT plus half AT square, this is second equation of motion. Third is V square is equal to U square plus 2 times of A into S. Let us discuss about the notations, where V stand for the final velocity, V stand for final velocity, U stand for initial velocity, where A is a symbol of acceleration of particle, In this case, our acceleration value is simply g. It is equal to 9.81 meter per second square, where t is time of journey, and its unit is SI unit is of time is second. We will measure our time value in second. Okay. So the another symbol S, it is the indication of displacement of particle. Is indication of displacement of particle. Or displacement is basically the change in position. The change in position with respect to time is known as displacement of particle. Okay. So I think this information is sufficient to solve the problem of motion under gravity. So let us discuss an illustration so that we can apply the concepts. Okay. So we'll start a small numerical related to this topic. Okay. So first question on your screen is, if a particle is thrown upward with a velocity v naught. If a particle is thrown upward with a velocity v naught, then find maximum height attained by particle. Okay. Also calculate the time when it attains the maximum height. Okay, so this is a simple illustration. So I hope you all have the basic idea of this illustration. So starting with the concept how we will solve this problem. Before solving this problem, I think we should have a brief idea about sign convention. Okay, before solving this problem, before solving this problem, we will discuss about sign convention. Okay. If I is the initial point of journey, if f is the final point of journey, if your final point is in right direction, then right direction is taken as positive. If right direction is taken as positive, then left direction is taken as negative. Okay, if right direction is taken as positive, then left direction is taken as negative. In same fashion, if initial point is at origin, for example, and final point is above the horizon, then the values are taken as positive, and if journey is downward, then parameters are taken as negative. Okay, so we should have the brief idea about the sign convention before solving the problem of motion under gravity or motion in straight line. Okay, so if we read this question once again, and if we try to draw the diagram of this problem, then this is the problem. This is your ground, this is your horizontal plane, this is your ground, this is your horizontal plane, and I am projecting a particle with velocity v naught in upward direction, and my question is how much height it will attain before coming back to the ground, and what is the time taken by this particle to attain this maximum height. So what are the values we are knowing from the statement? I think initial velocity of journey is given, and I do have the idea of final velocity of the journey too. Initial velocity of particle is v naught, positive or negative. This is in upward direction. Upward direction is taken as positive. Upward direction is taken as positive. So it is positive v naught meter per second. Finally, when it attains the maximum height, its velocity, its vertical velocity becomes 0. So final velocity of particle is 0 at the top. So this is the initial position, this is the final position, this one is the maximum height attained by particle. This is the maximum height attained by the particle. Your displacement value is h max. Positive or negative? I think this is above the horizon and upward journey is taken as positive. So we will select the displacement as positive h max. Okay. So now our question is how much this maximum height is possible with the initial velocity v naught. I think we do have the idea of acceleration of particle. It is minus g meter per second. Why it is negative? Because gravity is acting in downward direction. Okay. So we will apply the second equation of motion. We will apply the second equation of motion, and we try to get the answer. Okay. So applying the second equation of motion, we will get S is equal to ut plus half a t square. Okay. Oh, we cannot apply this equation because we don't have the idea of time also. So we'll try to use the third equation of motion. Third equation of motion is v square is equal to u square plus 2 time of a into s. We'll put the values. The final velocity of particle is 0. Initial velocity is v naught square plus 2 time of minus t into h max. This is the value we need to calculate. Okay, we'll try to solve this mathematical equation. We will get the maximum height as this if 2g h max is equal to v naught square, then h max is equal to v naught square divided by 2g. This is the maximum possible height attained by the particle with initial v naught velocity. Okay, so simply we will put the value of v and we can have the idea of maximum height attained by the particle. Now second question is find the what will be the time of attaining the maximum height. Time of attaining maximum height is, I think we do have the idea of displacement. It is h max. And we do have the final velocity value. It is 0. Initial velocity is u. Okay, we can simply apply the first equation of motion as v is equal to u plus at. Putting the values, we will get v is equal to 0. Initial velocity is v naught. Acceleration due to gravity is minus t, and time taken of journey is t. So t value is v naught divided by g. So by simply putting the value of v naught, we can get the idea how much time it will take before attaining its maximum height. So I think you all do have the idea how to solve these kind of problems in mechanics. So thank you everyone for watching this video. Please subscribe our channel and stay tuned. Thank you.